Welcome back to the other episode called Chemical Equation. Chemical equation is a symbol. It's a symbolic representation of a chemical reaction showing the reactants and products involved and the direction in which the reaction proceeds. It uses symbols and chemical formula to describe this process. So what you need to understand here is in any chemical equation, we already call the reactants and the product and an arrow. A single arrow indicates that the reaction is irreversible, which means it can only go in one direction. So we have what we call double arrow. This double arrow means the reaction is reversible. It can go both forward and backward reaction. So this is what you need to know in any chemical equation. So the reactants are the substance that undergo chemical changes and appear at the left-hand side of the equation. And the product are the substance formed during a chemical reaction and appear on the right side of the equation. Now you state the symbol. State symbols are symbols used to indicate the physical change of a substance in a reaction. They are written in a bracket after the symbol formula of the compound. These are denoted as solid, liquid, gas, or aqueous. So it means whether this substance that are written is indicating whether this compound or an element is in the form of solid or liquid or gas or aqueous. They are talking about their states of matter. So they are very, very important, and they are also mostly written in a form of what? In a bracket form. So it's very, very important that if you are writing any equation, you indicate whether this is a gas or solid or liquid or aqueous. So let's take an example here now. We have what we call hydrogen plus chlorine. Now, okay, before we go for that, let me show you this. I brought clay for our new house. Now I represent iodine gas, brought represent bromine gas, clay chlorine gas, for fluorine gas, our oxygen gas, new nitrogen gas, and house hydrogen gas. Now in these are called the diatomic molecules. Now anytime they appear in a chemical equation, here, they must possess these two, which shows that, or which indicates that they are diatomic molecules. So it is wrong that to write these diatomic molecules in a chemical equation without indicating these two. Now, which means now here should be 2, here also should be 2. So this shows that hydrogen gas reacting with chlorine gas at the reactant. This is called the reactant side. The left side is the reactant side and the right hand side is the product side. The reactant side are the one that react. They react and produce the product side. Now, for you to be able to write the product, you need to go back to the chemical formula. That is, what are reacting here is hydrogen and chlorine. Now, in the chemical formula here, you don't need to indicate these two. This two does not show that, or does not mean that the valency of hydrogen and chlorine is 2, 2. No. It indicates that, or it shows that there are diatomic molecules in a chemical equation. It needs to be indicated in a chemical equation that there are diatomic molecules, but it does not really mean that the valency of hydrogen is 2 or the valency of chlorine is 2. That does not mean that. It does not indicate that here. So now in the chemical formula here now, hydrogen is in group 1, so the valency is 1. It has only 1 electrons in the atom or cell. So therefore the valence is 1. So chlorine, which has 7 electrons in aromatic cell, 7 minus 8 is 1. So when you interchange them now, or you cancel them, you have HCl. So which shows that now at the product side you should write there HCl. I guess it is simple, or I guess it is easier, or it's understood. Now let's look at another example. Let's say we are given a compound called, let's say we are given sodium reacting with chlorine. Now the same process, I told you that. Hence chlorine is part of the diatomic molecules. The two should be indicated, which shows that it should be a chlorine gas. Sodium reacting with chlorine gas. Now, for you to be able to write the chemical formula here, for you to be able to write the product, you need to write the chemical formula of that compound. Now, what is the chemical formula of the compound? What I want are reacting here is you have sodium and chlorine are reacting. I told you earlier on that it does not mean that this 2 is the valency of chlorine. No, the valency of chlorine is 1. Hence, chlorine belongs to group 7, and 7 minus 8, you have 1. So sodium belongs to group 1, the valency is 1. Hence, they are all the same. They cancel, then you interchange them, you have NaCl. So this NaCl should be written at the product side, which means if sodium reacts with chlorine gas, they're going to form a salt called sodium chloride. So this is a clear example on how to write a chemical equation. Now let's look at another equation. Let's say if you happen to be given a compound, let's say Na2CO3 plus HCl. Now anytime you are given such kind of compound, remember this is a carbonate. This is sodium carbonate, or it's called sodium triiodocarbonate 4. So here now, this is an acid, it's a hydrochloric acid. You need to understand that whenever acid react with a carbonate, they form 3 things. They form salt, they form water, and a gas. What is the gas? The gas is called CO2, or carbon 4 oxide. So whenever acid react with carbonates, they form salt, water, and a gas. Now let's say now this is sodium, this is chlorine. So the sodium will react with chlorine to form sodium chloride. Now it is left with CO3 and hydrogen. Now it means now one of the oxygen will react with the hydrogen to form water. And also, if you remove 1 oxygen here, it will be left with what? 2 oxygen. Now 2 oxygen with the carbon that's going to be formed CO2. So this is how you write a chemical equation. Now if you want to indicate their state of matter, that is going to be in the form of a bracket. Now this sodium carbonate is in the form of what? aqueous. You write the AQ in bracket. This HCl is in the form of what? aqueous in a bracket. This sodium chloride is in the form of solid. This H2O is in the form of liquid. And this CO2 is in the form of gas. So it is also very important also to be indicating the states of matter of the element, or to indicate whether they are aqueous or they are solid or they are gas. Yes. So let's look at another example. Let's say last example. If we are, let's say we have calcium hydroxide. Yes, calcium hydroxide reacting with, let's say, ammonium chloride. So ammonium chloride reacting with calcium hydroxide. So take note again, if calcium hydroxide react with ammonium chloride, so we mean this reaction is between calcium hydroxide and ammonium chloride to form, it forms 3 things here. It forms calcium chloride, it forms water and ammonium gas. Whenever ammonium chloride react with other substance like, let's say, calcium hydroxide, they also form three things. They form a calcium salt, let's say salt, water, and ammonium gas. Now, let's say here now, what is this type of salt that is going to form here? The salt is going to be what? This calcium will react with this chlorine to form calcium chloride. And remember now, how do you that formula is? You have calcium and chlorine. Calcium is in group 2, the valence is 2, chlorine is 1, the valence is 1, right? So now the interchange, you have now CaCl2. Now you write here now CaCl2. This is a salt plus. Now remember, it forms what and what? A salt, water, and ammonia gas. Now, this is OH. Now, this OH now will take one hydrogen here. This is NH4 as ammonium. So if one hydrogen is being removed, added to this OH here, is going to form H2O. Now what we left there is now NH3, because if you remove one hydrogen here, it's going to be left with how many hydrogen there? 3 hydrogen. So go them now NH3. Now if you don't know now the state of matter or their aqueous, whether they are aqueous or their solubility, they are solid or they are liquid or gas, you check here. So this calcium hydroxide is aqueous. This ammonium chloride also is aqueous. Again, this calcium chloride is a solid. It's a solid, S. The water is a liquid and ammonia is a gas. So I believe